Please see the link in the description to download a worksheet for this video. Experiments can be dangerous. If you are a child, never do experiments unless your parent, guardian, or adult educator says it's all right and is there with you the whole time. If you have not already done so, we suggest that you view parts 1 and 2 of this scientific method video mini-series before viewing the rest of this video, since they introduce concepts and terms that are used in this video. Ever since we changed the web page as noted in the prior video, our petting farm is getting more visitors. This is the current page, but it's now been 2 months, and our business partners think we could get even more ticket sales if we add more photos to the home page. We decide to do another experiment using the scientific method. The scientific method has 4 basic steps, which we can remember with the word data. The first step is to decide on a question. We'll use this question: does the number of photos affect the number of tickets sold? The second step of the scientific method is to make a hypothesis, which is a guessed answer. For reasons we will demonstrate later, it can help to put the word depends in the hypothesis when we're first learning how to do research. Here's one we can use. The number of tickets sold depends on the number of photos on the homepage. Now we're ready for the third step, which is to test our hypothesis with an experiment. Several of our partners designed 4 new web pages with more pictures. These are the 4 new pages. Since we currently have 1 picture on the homepage, that will be our control. We'll have 3 experimental groups, each with a different number of photos. Please note that the only difference among the pages is the number of photos. For example, the banner with text and the Buy Tickets button are identical. The number of photos is the independent variable. The value of that independent variable will differ for each page from 1 to 4. Next, our website designer asks us when we would like to have the pages displayed. These are the options: on different days or all on the same day, but taking turns throughout the day. The reason we chose to have them taking turns throughout each day is because it's possible that some people only visit the website on some days, such as a Thursday or Friday when they are planning their weekend's activities. If we only showed 1 page per day, then whatever web page is shown on those busy days will have an unfair advantage over the web pages shown on less busy days. For the next week, we run the experiment. The number of tickets sold is our dependent variable. Since the web pages look the same except for the number of photos, and since we are displaying them at the same time and on the same days, then any difference in the tickets sold should be due to the difference in the value of the independent variable, which is the number of photos per page. And here are the results. We're now down to the last step of the scientific method, which is to analyze the results. As we will learn in high school and beyond, normally we analyze research data using a branch of math called probabilities and statistics. At this level, we will use graphs to look for trends. To graph the results, we need to know which variables are controlled, dependent, and independent. Let's do a quick review of these definitions. The independent variable is the variable whose value differs among the groups and whose value we set. In this experiment, it is the number of photos per web page. We set its value to 1, 2, 3, or 4. The dependent variable is the variable which we measure. In this case, it's the number of tickets sold using each web page. The controlled variables are everything else. That includes the rest of each page's appearance, plus the date and the time that they were shown. Should we use a bar graph or a line graph to graph the results? If both the independent and the dependent variables are numbers, then we use a line graph. In this case, the values for both the dependent variable and independent variable are numbers, so we can use a line graph. The reason gets back to using math to analyze data. Please make a sketch as to what the graph will look like. For the rest of this video, we will review how to graph numbers that are x, y input, output, dependent, and independent values, and we'll offer memory tips for these. If you are confident in your skills and want to see the final answer, please skip to the end of the video. Can you tell which color is the x-axis and which is the y-axis? One way to remember that the vertical number line is the y-axis is to think of a tree that is also vertical and has branches that look like the letter Y. In math, we learn to plot points from a table that looks like this. Each row has a pair of coordinates for a specific point. One column has the x value and the other column has the y values. To plot a point, we circle a row, find the x value on the x-axis, then extend that line. Next, we find that row's y value on the y-axis and extend that line. The place where the two lines cross is where we plot the point. We repeat this for each row of the table. In math, we learn about input and output tables, which also contain values that we can plot on the x and y axis. These are often part of a math question related to a rule, also called a function, that converts an input number into an output number. One way to remember that the outputs map to the y-axis is to think of the oranges in the orange tree that also begin with the letter O. When we do research, we map the independent variable values on the x-axis and the dependent variable values on the y-axis. If we draw the stem for those oranges, then it'll look like the letter D, which stands for dependent variable. To summarize, the vertical axis of a line graph is where we map three different things depending on the math or science test question. We can map the y value of an xy coordinate. We can remember that because a tree is vertical and has a branch that looks like the letter Y. We can map the output value of a math function or rule. We can remember that because the word oranges in output both start with the letter O. And we can map the value of a dependent variable from an experiment in business or science. We can remember that if we remember that oranges with stems look like the lowercase letter d. In contrast, the x-axis has the input values and independent variable values. Both of those words start with the prefix in. Now that we know what values are mapped to the x-axis and y-axis, we need to be able to look at a hypothesis and identify which is the dependent variable and independent variable. If the hypothesis has the word depend in it, then the first word is the dependent variable. You can remember this because if you write a sentence with the words lamb, mother, and depend, then the lamb comes first. And dependent variables are dependent, just like lambs are also dependent. In this experiment, the number of tickets is the dependent variable, so it will go on the y-axis. The number of images is the independent variable, so it will go on the x-axis. Although we could leave the y-axis written with large numbers, we usually make them small numbers, but instead change the label so it has a multiplication factor. We'll find the points for this graph in the same way that we did for a table with x and y coordinates. We just have to remember to look at the vertical label, which tells us that the red 2 represents 200, and the red 3 represents 300. So the value for 250 is between them. We can then repeat this process for all of the points and get this graph. To find a trend, we read a graph from left to right, just like we read a sentence. Since the points are getting higher, we say that the trend is increasing. The full analysis is, as the number of photos per webpage increases, the number of tickets sold increases. This suggests that our hypothesis is true, though technically we cannot say whether our hypothesis is likely to be true or false until we use statistics. If we were doing this experiment as part of science research, then we would publish our results in the last step of the scientific method. But many experiments are done by business, such as this example with a website, which is called A/B testing. We do not publish these experiments. Here's a summary of the topic we just covered. Please pause the video to read this if you wish. If you're interested in practice tests that are similar to state exams, but with detailed, colorful explanations for each answer, then please see our apps in the App Store. Many of these are free and none expire or limit their function. Since we only make educational products for children, none of our apps have third-party advertising, in-app purchasing, or connect to the internet. Please subscribe if you'd like to be notified of future educational videos we make. Thanks for your attention.